In this example, we're going to work a couple of problems with fraction division. Now there's a set of rules at the top of the page here, but before we launch into the mathematical rules, I want to be sure that you have intuitive understanding for what division is with fractions and how it works. So if I have 2 divided by 1/4, then let me take a whole that's divided into 4 pieces. So 1, 2, 3, and there's another one. These aren't the straightest wholes. There we go. So there's 1, 2 divided into 4 pieces. So if I want to divide 2 by 1/4, I want to know how many 1/4 are in 2. So here's 1, 2, 3, 4, 5, 6, 7, 8. So the result of 2 divided by 1/4 should be 8. Well, let's see how that would work with our mathematical steps. So if I have 2 divided by 1/4, 2 is really 2 over 1. Write that as a fraction. I'm going to change my division to multiplication and use the reciprocal of the second fraction. So when I multiply 2 over 1 times 4 over 1, I get 8 over 1, which is, of course, 8. So those results match. So there's a very specific reason that we use multiplication by the reciprocal when we start with fraction division. Let's see how that works in the second example. I have 2 divided by 2/5, so I'm going to take my same whole, also kind of a crooked whole, 1, 2, 3, 4. I'm going to divide it into 5 pieces, so I'm going to duplicate that here, 1, 2, 4, and I want to know how many 2/5 are in 2. So here's 1 2/5, here's 1 2/5, that would be 2, there's 3 of them, 4 of them, and 5 of them if I count this one and this one together. So the result here should be 5. So let's see how that works with the actual rules. So 2 is 2 over 1. I'm going to change my division to multiplication. The reciprocal of 2/5 is 5/2. Now I have a common factor of 2 that can be removed, leaving me with 5 over 1 equals 5. So again, those results are the same. So try to remember this kind of intuitive approach, and that approach is the reason behind the rules that we use for fraction division.